Hello everybody. Today we're going to be talking about the identity and inverse matrices. This is section 4.7 in your book. Remember to take notes and bring any questions you have with you to class. So first off, we're going to talk about what an identity is. In math, in general, identity is a number that you have to multiply by to get equivalent numbers. So like for multiplication, we have 1. 5 times 1 equals 5. So this is handy. That if you need to have, say, a denominator of 40, like in the example, in the fraction 3/8, we can multiply 3/8 times 5 over 5, which, if you recall, 5 divided by 5 is 1. So we can multiply any number by 1, and it doesn't ultimately change the number. And then, as you may know, the identity for addition is 0. It's the same kind of idea. So then we have the inverse. The inverse is a number when multiplied by another number, it equals 1. So for the example here, we have 4 and 1 times 1/4. 4 is the same as 4 over 1, and we got 1/4. Then multiply 4 over 1 times 1 over 4. We get 4 over 4, which equals 1. Okay, and that works with everything, not just anything with 1. So we have in this other example 4 over 9 and 9 over 4. And since we get 36 over 36, we get 1. So the inverse of 4 is 1/4, and the inverse of 4/9 is 9/4. So now let's look at what that looks like in a matrix. The identity matrix is a square matrix with ones down the diagonal. So in a 2x2, we have this matrix here on the left, and then a 3x3, we have this matrix here on the right. And then the ones will go down the diagonal in the same way, always from the top left to the bottom right. And you notice there's 3 ones in a 3x3 and 2 ones in a 2x2. Okay, so now how do we find the inverse? So we find the inverse by finding the matrices that when we multiply the two matrices together, we're given the identity matrix. Okay, so we're going to talk about how we do that. This is really the meat of this section, is how we do that. So to find the inverse, first thing we're going to do is we're going to find the determinant of our matrix. So we have this example matrix here, 2, 8, -1, and 3. So remember to find the determinant, we multiply our diagonals and then subtract. Remember, it's always A times D, so going from top left to bottom right, minus B times C, which is top right to bottom left. Okay, so we have 2 times 3, which gives us 6, and then 8 times -1, which gives us -8. So we're going to end up with 6 minus -8. Remember, we subtract a negative, we get a plus, so 6 plus 8 is 14. Next thing we're going to do is we will flip the diagonal of the top left and bottom right numbers, then change the signs of the bottom left to the top right. Okay, so we take that 2 and that 3 and we switch their positions. Okay, and then we take the 8 and the -1 and change their signs. So the 8 becomes -8, the -1 becomes +1. Last step, we're going to take those two things and put them together. We're going to take the determinant and put it under 1 and multiply it by our new matrix. So pretty much what we're doing is we're taking our new matrix and dividing it by the determinant, which is the exact same as multiplying it by the fraction that like we have here. So we take the determinant, which was 14, put it under the 1, and then multiply it by our new matrix. Last step is simply to see if that works. So if it works, we should be able to take that inverse matrix and multiply it by our original matrix. And when we do that, it will cause us to get the identity matrix. Okay, so as you see here, we go through and multiply. So remember that when we multiply, we do row times column. So we do 3 times 2, get 6. Then -8 times -1, you get +8. So we get the 6 plus 8 up there in the top left-hand corner. And then we just go on go on the same way as we've learned in past sections. And we get our new matrix down here of 14, 0, 0, and 14. Now, when we multiply by scalar multiplication with the 1 over 14, we end up with 1, 0, 0, 1, which, if you recall from a couple slides back, is the identity matrix. So that means that our inverse matrix of 1/14 times 3, -8, 1, and 2 is in fact an inverse. Now, can there be matrices that don't have an inverse? And the answer is yes. When we look at the determinant, we want to make sure that it does not equal 0. If it equals 0, that means that that there's no inverse for that matrix. Okay. Now, if you remember, when you type in your calculator, any number divided by 0, we get an error, and it says something like divide by 0 error or something like that. Okay. So since a fraction cannot have 0 for a denominator, there would be no inverse. Here are survey questions. Please come in class with these answered, and have any questions ready for us when you come in.